Gorman, and I am the product owner for stream processing here at Cloudera. And I'm going to lead you through a quick 10-minute demo on how to use SQL Stream Builder to build a hypothetical fraud processing job. All right, so let's jump in. What I'm looking at here is Cloudera Manager. Should look fairly familiar. I just want to point out a couple services that I have. So I have Apache Flink here. We're going to be using that as the underlying processing engine. I'll talk a little bit about how that works. We're going to be using data from Kafka. That's going to be our input and our output for this process. We're going to be showing how SQL Stream Builder can be used to use SQL to create a stream processor that detects fraud. And I'm going to show Streams Messaging Manager briefly to talk about the data. So let's start there. We'll go into Streams Messaging Manager, and I'll start the UI. And now have a listing of all my topics. Let's go over here to topics. And what I'm going to do is search for authorizations. So this is my input topic. This is a listing or an event stream of various point of sale transactions. Let's just dive into the data itself. So like I said, this is hypothetical point of sale transactions. So imagine these are authorizations from, say, gas stations, and we want to perform some fraud analysis on them. And so I've kept the example relatively simple, so it's easy to kind of reason about. So we've got a card ID here. We've got a latitude and a longitude in terms of the location or position of the authorization. We've got an amount, and we've got a user ID. So pretty simple JSON formatted data. It's coming in as an event stream. I've got a Docker container that's generating this data and sending it in as a stream. All right, you can also look at various metrics, by the way. You can look at how many partitions you have. You can count the messages in and out and bytes in and out. In this case, I have 3 replica, 3 partitions, and 3 brokers. So relatively simple topic and easy to kind of use in this example. Let's add a new topic for our output. While we're here, I'm going to call this one fraud. We'll make it similar to the other one. So this will be a typical delete policy, cleanup policy, 3 partitions. We're going to name it fraud. Cool, so now we've added that topic, and we're going to use that in a second here in our processing. All right, let's go back to Cloudera Manager, and now let's pull up SQL Stream Builder. Okay, before we jump in there, I just want to point out a couple components here. We have a materialized view engine. I'll show how to create materialized views in a second. We have the streaming SQL console itself, which is responsible for doing the input and output as I type. That's actually the tool that we're going to use to run our queries. And then we've got the underlying SQL engine, and that component is responsible for parsing queries, building the jar, deploying it out to the cluster, and things like that. So let's jump into the console itself. So here we are in the console. This should look like a regular SQL window that you're used to seeing. What's a little bit different about this one is this is designed to run continuous SQL. So continuous SQL is a little bit different than just normal SQL you may be used to. Instead of returning a result and finishing, it's going to continuously process that from some source to some destination. So let's dive into a query and talk through it. Okay, so this is a simple aggregation query. This should be familiar to anybody who's run SQL before. In this case, we're going to be selecting a user ID from that JSON document that I talked about before. We're going to be summing the amount over a time window, a 10-second time window, grouping by that time window and the user ID. Okay, so a relatively simple computation. And the table is called authorizations. So let's dive in and talk about what that looks like. So where did that come from and how is its schema defined in SQL Stream Builder? So if I go to tables here, you can see I have authorizations defined. The schema for it, I can just detect the schema. I already did this before, but you can just click on detect schema, and it's going to go out to the topic itself. It'll read the data that I just showed you from Streams Messaging Manager. It's going to infer types from that JSON document and then build us a schema. Also to note is event time. We're going to use Kafka timestamps for our event time. You'll notice that I have no timestamp in my data itself. We're going to go ahead and use Kafka's timestamp for that. So that's why we have this selected here. You'll notice again, we said it's JSON, it's the topic authorizations, it's connecting to our local CDP Kafka, and I've named it authorizations. There's also some properties you can set, right? So we can read from the beginning of the topic, we can read from the end, and we can set consumer group or any other context specific attribute that would be supported by Kafka itself. Okay, so that's the definition of the table, and I can actually do things that you would expect, like describe authorizations. And I can run that, and that describes the table for me. So that gives me a feeling for what it looks like. So let's go ahead and run that simple query. Let's pull it from history, and let's just run that, and we'll talk through what it's doing. So when you run a query in SQL Stream Builder, it goes out, it parses the grammar, it looks for the schema and makes sure the schema lines up and there's no errors there like typos or misspellings. Once that's done, it goes ahead and creates a jar, and it deploys that jar out to the cluster and starts it running as a Flink job. Now, what you'll notice is I didn't use an IDE, I didn't write Java, I was just simply typing in SQL, and now I start to see results. One of the things I wanted to point out here is that these results are sampled. So imagine a stream of water going through a pipe, and imagine a clear section of pipe where we can look in and see the results of the data coming through. So this isn't, like I said, with continuous SQL, it's never going to end. It's just going to continuously process the results to some sync. So let's do that. Let's start our fraud job here and create a production quality fraud job. So in this case, we're going to use match recognize. Match recognize is the complex event processing capability and grammar within SQL Stream Builder and Flink SQL itself. We're going to partition by card. We're going to order by that event timestamp. We're going to go through 3 different patterns, 0 to 1,000, 1,000 to 2,000, and 2,000 above, within an interval of 1 minute. So what we're saying there is, if someone's at that gas station and they're authorizing something between those different steps in a 1 minute window, we want to call that fraud. So we're going to call that our production fraud job. And what I'm going to do is I'm going to actually let's go ahead and create an output table called fraud. I'm going to pick that cluster. I'm going to pick the fraud topic we created earlier. It's JSON formatted. In this case, I'm going to call it a dynamic schema. So that's whatever the output of the query is going to be the schema. I don't need to worry about any other settings. I'm going to save that change. So now I have fraud. I can go back here and create fraud as my output. I'm also going to create a materialized view. And this allows me to use that data in notebooks. It allows me to use it in business intelligence tools, or maybe in single page apps. I can just use the REST endpoint in a single page app. So let's select the card as the primary key. I'll use my API key here that I created. Then I'm going to add a query, and we'll just call it fraud. And I'm going to select all the columns. I'm not going to add any filters, and I'm just going to save that change. So now I can go back and let's just run this query. So this job is going to start. Again, I'm going to go out. It's going to go out, start the job. We can go here and actually look at the job in Flink. So I'm going to pull up the Flink UI, and we'll see all the operators for the process. You can see that I'm pulling from a source. We're actually doing the row time attribute filter, and then we're doing the match recognize over here. You can see that it's running checkpoints and saving state along the way. There's no exceptions, etc. So cool. So we've got that running. We're getting results now in the console. We can see those. So that's our fraud job. We also can see that the data is being spooled to a materialized view via that REST endpoint. So I could be using that in my notebook or anywhere else. And if I want to go back here, let's go to Streams Messaging Manager and let's look at fraud. And we should see our output in fraud here. So there you see it. So there's our fraud output. Now we could send that to another application. We could be processing that downstream, that kind of thing. So there you have it. Really quick, 10-minute-ish end-to-end demo on how to use SQL Stream Builder and Cloudera Manager, building a fraud pipeline end-to-end using Flink, Kafka, SQL Stream Builder, and Streams Messaging Manager. Thanks.